So on this sheet, we need to draw a hand. So I'm really not good at drawing a hand. You guys try your best. You could. That'd be kind of big, but that's not too terrible. I've drawn worse hands, actually. All right, and then the pinky. What angle does that represent, the pinky? 0. And then as I go up, what's next? Good. 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 And the thumb? Nice. All right, now if I want to use the hand trick to find the sine of an angle, what do I do? Like, you pull down the finger for that angle, and then how do you find the sine? Bottom. Square root of the bottom fingers over 2. Nice job. What about the cosine? Okay, square the top over 2. And the tangents? Nice job. All right, so that's how we are going to need to use the hand trick today to solve equations. All right, another thing that I'll let you guys get that written down. All right, and then we're also going to need to know what pi/6 is as a reference angle in quadrant 2 and in quadrant 3 and in quadrant 4. So somewhere, draw an x and y axis. All right, and then I'm gonna draw kind of like an x. So we'll say this angle is pi/6. And then, woo, there you go, an x going that way. Bless you. So this angle is pi/6. All the rest of these have a reference angle that is pi/6. So we need to figure out in quadrant 2 what angle has a reference angle of pi/6. What do y'all think? 5 pi/6. So it's pi/6 less than pi, so 5 pi/6. All right, and then quadrant 3 is pi/6 more than pi. 7 pi/6. All right, and quadrant 4 is pi/6 less than 2 pi. 11 pi/6. All right, that is going to be helpful whenever we're solving these equations. All right, and we have to do it for, same thing for pi/4 and pi/3. Bless you. Now, pi/4 to me is the easiest one to remember because you just go to the next odd number as you're going around your quadrants. So in quadrant 2, we have 3 pi/4. And then just keep going to the next odd number. And that'll give you all the pi/4s. All right, and then we need one more of these for pi/3. Okay. So the next one over is going to be 2 pi/3. All right. Then pi is technically 3 pi over 3. So that's going to be right here. And then we would have 4 pi over 3, 5 pi over 3, and then 2 pi is 6 pi over 3. Did I say that wrong? Yeah. Okay. And so we need to know that. All right. And then we also need to know when the sine of these angles and when the cosine and tangent are positive and when they're negative. What acronym do we use for that? All students take calculus. Good. All right, and then there's one more thing we need to draw. And then I think we'll have everything, all the background knowledge we need. All right, so somewhere, so we've taken care of pi over 6, pi over 4, pi over 3, and the other quadrants. But we need something for like pi and 3 pi over 2. For 0 and pi over 2, we can use the hand trick if you want to. You also can use the unit circle. All right, so we would want to do a point that's 1 unit away in each direction. You can draw a circle if you want. I usually don't actually draw the circle. I just put my points. All right, and then if I'm gonna use these points and I wanna find the sine of an angle, what do I do? What do I use? Do y'all remember? We'd use the y for the sine. Just use the y coordinates. And then for the cosine, we're going to use the x coordinates. All right, what about the tangent?
Y over X.
Good job, y over x. Now you also can use if you remember what the graph looks like, you can use the graph also. I'm not going to have you draw the graphs unless you just want to do that on your own. Okay, so all of these things we need to do what we're doing today. And like I said, we'll recreate this every day for a while, and then hopefully you can do it on your own. Okay, so let's look at the note sheet. We're going to start off with just a couple of pretty basic trigonometric equations, and we'll move our way up to more complicated ones. But for example 1a, we want to find an angle x that has a cosine that is 1/2. All right, so what quadrants is the cosine positive? Because this is positive 1/2. 1 and 4. So I know I'm going to have 2 answers in this interval. So this one, I should have said this, but this one is, we're just looking at the angles between 0 and 2 pi. There's a bracket on 0, so 0 is included in the interval, but 2 pi is not included, so we won't give 2 pi as our answer. All right, so we're looking for an angle in quadrant 1 and an angle in quadrant 4 that have a cosine of 1/2. So for cosine, we just said that if we're going to use the hand trick, it is the square root of the top fingers over 2. So if we want, to take the cosine and get 1/2, how many top fingers do I want? 1. So which angle, sorry I'm zooming around, which angle would give you one top finger? Pi over 3. Because the top finger is your thumb. All right, so that means that in quadrant 1, x is going to be pi over 3. All right, and we already said there's two answers, one in quadrant 1 and one in quadrant 4. So what was pi over 3 in quadrant 4? 5 pi over 3. So those are our two answers. Let's see. All right, let's look at B. For B, we want to find an angle x that the sine of it is negative square root of 2 over 2. So what quadrants are we looking at this time? Good. That's where sine is negative. So I know my angles are going to come from quadrants 3 and quadrant 4. All right, and then for this, the hand trick on the sine is to square root of the top fingers. Nope, just kidding. It's the square root of the bottom fingers over 2. So how many bottom fingers do I want? 2. I want 2 bottom fingers. So what angle is that? Pi over 4. All right, is pi over 4 in quadrant 3 or 4? No, so it is not one of my x's. So I'm gonna just kind of write it over here. It's the reference angle. So what would that be in quadrant 3? 5 pi over 4. And in quadrant 4? 7 pi over 4. Nice job. All right, any questions about that before we do something that's a little bit more difficult? Okay, so there is a graph on here. Don't worry, we're not doing any graphs. I'm just gonna use this graph to explain the problem. So when you're not given an interval in which to find the solutions, there's an infinite number of solutions, and I'll show you that using the graph in just a second. And so what we have to do is give a general solution. So if it just says solve the equation, there's an infinite number of solutions, so we'll have to represent. All right, so let's just start off solving this equation for x. What would you guys do first? You would add 1. Okay, and then what would you do? Okay. Okay, so we're looking, this is the same one we just did. So because we've already done it, we just did it here. We had cosine of x is 1/2. I already know that I'm gonna have pi over 3 and 5 pi over 3, but don't write them beside each other. Because there's more than just those answers. All right, so what I have graphed is the cosine of x. And so what I want to do is find when that cosine of x is equal to 1/2. So 1/2, I would say, is about right here. I'm going to continue that. So the answer, if we were solving by graphing, the answers would be everywhere where these two graphs intersect, which is on this one, I have like 2.5 periods. There's 1, 2, 3, 4, 5, 6 solutions just here. And then it just keeps repeating this pattern over and over again. So there's no way we could list out every solution. So we have to represent it generally. So looking at what we got for our answer, what would you guys say this point is right here where it crosses? That's going to be pi over 3. And that makes sense. It's between 0 and pi over 2. Okay, and then this one right here is going to be 5 pi over 3. All right. Now I can guess what this one is. It's not a guess. I know what this one is. I know that this point right here is pi over 3 plus 2 pi. Where do you guys think that 2 pi came from? Yeah, the period. All right, and then I know this one is going to be 5 pi over 3 plus 2 pi. What do you guys think this one is? I know it's got a pi over 3. 4 pi, good. All right, and then this first one, that's going to be 5 pi over 3 minus 2 pi. So what we do to represent our solutions is just add a multiple of 2 pi to each solution. So we would just do plus 2n pi, where n is just represented by some integer. And that will represent all of our solutions. Okay, so to give a general solution, we're going to add 2n pi for the functions that have a period of 2 pi, which is going to be sine, cosine, secant, and cosecant. And then for our functions that only have a period of pi, like tangent and cotangent, that's what we add in pi for tangent and cotangent. All right, for B, I'm gonna change this one. Looking at what I'm gonna have you guys do in your worksheet, I wanna show you something I haven't shown you yet. It's not on this sheet. All right, so let's just mark it out. We're gonna change it to cosecant of x minus 2 minus 4 is gonna equal cosecant of x. Hopefully it's gonna work out. I think it is. Equals negative cosecant of x. Sorry. All right, so think about when you first started learning about solving equations. What did you guys do when you had variables on both sides? Get them all on one side. So that's what we're gonna do. So I'm just gonna go ahead and move my cosecants all on the left. And since this is a negative cosecant, I'm gonna add a cosecant to both sides. Now, we don't have to go to the left side. It might be smarter actually to go to the other side, but it's fine. All right, and so then we're gonna add that 4 and then divide by 2. All right, so we do not have a hand trick for cosecant because we don't need one. What is the cosecant the reciprocal of? The sine. So what I would do at this point is I would just change this. If I know the cosecant of x is 2, what is the sine of x? 1/2. That is what I would do. Some people in my last class wanted to flip the hand trick rule, and that works too. It works fine. But I'm gonna go ahead and change it here. Okay, so what quadrants is x going to be in? Our original x's. 1 and 2. Now, remember, this is going to repeat a pattern, so I'm going to have multiple answers. All right, so if I'm doing the hand trick, first sign, I want the square root of the bottom fingers over 2. So that means I want 1 bottom finger. So what angle is that? Pi over 6. And then what angle is that in quadrant 2? 5 pi over 6. All right, and then I wrote them like this because these are not the only 2 answers. Our directions were just to solve. So we have to represent all of the solutions. And then since this was a cosecant problem, I'm going to add 2n pi to each of those. And that's going to represent all of the solutions. All right, are you guys okay? All right, this next one is slightly tricky. Just with knowing what to add, it's just kind of strange. But we're going to start off the same way. We're going to go ahead and solve this for tangent of x by adding 3 and taking the square root. All right, and then don't forget that when you take the square root, you have to do positive and negative. Just like we did with polynomials, we have to do trigonometric equations also. So what do you guys think about your quadrants here? It's going to be all of them. So the positives and the negatives for tangent. So that's all 4 quadrants. All right. So don't forget tangent. When we're doing a tangent with a hand trick, we're going to do the square root of the bottom fingers over the square root of the top fingers. So how many bottom fingers do you think you need? You need 3 bottom. And you can think of there's like a square root of 1 underneath there because that's just 1. So 1 top. So what finger is that? Pi over 3. Okay, so for tangent, I'm going to add n pi. So if you add pi to 3 pi or pi over 3, what do you get? Pi over 3. Oh, right, hold on. Yeah, 4 pi over 3. So that is my pi over 3 reference angle for quadrant 3. So just by adding n pi to it, I've taken care of 2 of my solutions. All right. So when I add n pi to the angle in quadrant 1, it gives me the angle in quadrant 3. So I don't have to do it again. If I did, it would kind of be redundant. You'd be given the same answer twice. So when I did this right here, I took care of quadrant 1 and quadrant 3. Okay. So what is my answer in quadrant 2? 2 pi over 3. Right? When I add pi to that, what do I get? 5 pi over 3. That is my answer in quadrant 4. Okay, so that has taken care of all 4 quadrants. And I know it's kind of weird, but it is kind of a shortcut if you're paying attention. All right, y'all okay? I have a few more. All right, this right here, I don't want to fill out. That's how I used to talk about it. I don't want to do that. So we're going to skip that and go to D. So you guys go ahead and take D, please, and solve it for sine of x. Did y'all get what I got? Okay, good. What quadrants are we talking about? We're talking about all of them. So when we have all the quadrants, even though normally on sine, we add 2 in pi. But if we have all 4 quadrants, we do not have to add 2 in pi. Because if I take the angle in quadrant 1 and add in pi to it, it'll give me the angle in quadrant 3. And then same thing for 2. It will give me the angle in quadrant 4. All right, so if you have this plus or minus situation, you can shorten it down to just 2 answers instead of 4. It doesn't matter if it's sine or tangent or cotangent or secant or whatever. You can definitely do that. All right, so in quadrant 1, which angle are we talking about? We have 3 bottom fingers. Pi over 3. All right, and then because we're talking about all 4 quadrants, we can just add in pi to it, and that takes care of quadrant 3, and then it takes care of every other angle in both directions. All right, and then when we do pi over 3 in quadrant 2, I can add in pi to it, and it's going to take care of the angle in quadrant 4, and then all the other ones as you have more and more periods. I know that is kind of confusing. Do you all have questions? Yes, ma'am. Okay, so because when I simplified it down, I got the square root of 3 over 2. That means for sine that I want 3 bottom fingers. And then I went to my hand trick. There it is. So 3 bottom fingers is pi over 3. All right, any other questions? Okay, couple more. Now look at the directions. If you notice, these directions tell you we want the answers in the interval. So we do not have to do the plus n pi plus 2 n pi. We just give all of the angles between 0 and 2 pi that work. Okay, so we're going to start off A the same way by solving it for sine of x. Now for sine and cosine, you do want to simplify that radical. For tangent and cotangent, you don't necessarily have to. It actually works out better if you don't. But for sine and cosine, you need to. All right, what quadrants are we talking about? All 4. Okay, so this is the sine. We want an angle, or an angle in each quadrant, that the sine is either positive or negative, square root of 2 over 2. So sine, we're talking about bottom fingers. So we want 2 bottom fingers. So what do y'all think? Pi over 4. So that's our quadrant 1 angle. And then remember for pi over 4, as you go around the quadrants, you're doing the next odd number. So then 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay. And then also, don't forget what you're doing when you're solving an equation. We're finding x values that we can plug in and have it be a true statement. So if you have your own calculator and you just want to double check yourself, you can. You can take, as long as your calculator's in radians, take those x's, put them in, and it will give you 0. Okay, so our last one we have this in factored form. Now we are going to factor trig equations, but not today. So today, this one is already in factored form, and so we can use that to solve it. So once you have an equation that's set equal to 0 in factored form, what do you do with those factors to solve it? You set them equal to 0. Okay, so this first one is already solved for sine, so we're going to leave it alone. The second one, we just need to subtract 1. Okay, so we want to find an angle that has a sine that's equal to 0, and then another angle that has a sine that's equal to -1. So if you're talking about sine and cosine, that is equal to 0, 1, or -1, that does not necessarily come from the hand trig. It's going to come from the unit circle, wherever that is. There we go. Okay, so the first equation was sine of x equals 0. So we want to find one of these angles, 0, pi over 2, pi, 3 pi over 2, that has a sine of 0. So we're looking for a y-coordinate that is 0. So what do y'all think? 0 and pi. Okay, so that's going to be 2 of your answers. You can just jot those down. X equals 0, x equals pi. All right, and the other equation was sine of x equals -1. So for sine, we're looking for a y-coordinate that is -1. So the third answer is 3 pi over 2. All right. Now for tangent, you can get 1 from the hand trick, right? So 1 and -1 for tangent are going to come from the hand trick, where there's the same number of bottom fingers as top fingers. What angle is that going to be? Pi over 4. So the tangent of pi over 4 is 1. But if it's a tangent is 0, then that has to come from the unit circle, or the tangent's -1, or the tangent is undefined. Not -1, sorry. 0 or undefined comes from the unit circle. 1 and -1 come from the hand trick. It's a lot to keep straight, I know. All right.